Hello everyone, I would like to welcome you all in my class of CIS 2168 Data Driven Design. This is part 3B of temporal analysis, and in this session again we'll focus on the statistical plot. In the previous session, that is in part 3A, we discussed bar plot. Here in this session, that is in part 3B, we will focus on box plot. So we'll see the basics about box plot and how we can use box plot for data analysis. I am Dr. Harimohan Pandey from the Department of Computer Science, and my email ID is given here. In the next slide, I have presented some basic information about the box plot. So this is a graph representing a box plot. Here you can see it has categories. It is representing categories in the data. So all in all, we have four box plots, four boxes, and each box will represent one category: category C1, category C2, category C3, and category C4. Some people refer box plot as whisker plot. So it is also called as whisker plot. And why we use it? We use it for explanatory data analysis and to visually show the distribution of numerical data. So we use it. It is called as it is also referred as whiskers plot. We use it for explanatory data analysis, and it is used to visually show the distribution of numerical data. Another important thing for box plot is it presents skewness of the data. So using box plot, we can display the skewness in the data, and we use quartiles. Or it is also referred as percentile, and average of the data. So box plot displays the skewness of the data. Using the box plot, you can see quartiles or percentile, average of the data. So here you can see this one is maximum value. It represents maximum value. This line represents the minimum value. This is nothing but the median. More detail about the box plot is given in the next slide. That is, box plot description is presented in the next slide. So here you can see in this slide a box plot is shown here. This is nothing but the box plot, and it is representing distribution of the data based on 5 numbers. So it represents distribution of the data based on 5 values or 5 numbers. And what are the 5 numbers? First one is maximum. So you can see the maximum value in the data using the box plot, and this is nothing but the maximum value of the data. Number 2 is, you can see the minimum value. Present in the data. Using this, you can see the minimum value of the data. Third one is it represents Q3. And what is Q3? Q3 is nothing but third quartile, that is this, or 75% quartile is Q3. So we call it third, is referred as third quartile. Fourth, we can get median value. So here you can see this is nothing but the median value. So we can get median value of the data distribution. And fifth, we can get 25% quartile, that is first quartile or Q1, or we call it first quartile the data. Another thing which we can get from these 5 values, which is interquartile range. And what is interquartile range and how we can get it? In order to get interquartile range, what we will do, we will apply the formula Q3 minus Q1 for a particular category of the data. So for a particular category of the data, if you want to get interquartile range, that is this, then apply the formula Q3 minus Q1, that is this one, minus 25% will give you interquartile range QR. So this slide just gives a basic description about the box plot and what are the data we can get by displaying a box plot for a given data distribution. So you can see, all in all, we can get 6 different numeric 6 different values: maximum, minimum, third quartile, median value, first quartile value, and interquartile range with the help of box plot. In the next slide, I have presented one example for box plot. So this example presents, this example is between teaching method. So you can see x-axis represents the teaching method, and here y-axis represents the score in any subject. So for this subject, 4 teaching methods have been implemented: the method number 1, method number 2, method number 3, and method number 4. And what we want to analyze, we want to analyze that, looking the box plot, which method is more effective for teaching the subject. So here what we can see that the median value is presented here for method number 4. Let me call it median value 4. This is M3, median value 3 for method number 3. This is median value 2 for method number 2, and this represents median value M1 for method number 1. Here you can see that the median value for M4 is higher than the other 3 teaching methods. Hence, what we can do? We can say that method 4 is more effective teaching method, because the median value, score value, is more. That is why the median value for M4 is 4. M4 is high. The box plot also reveals that median value of method number 1 is least. So M1 is the worst teaching method. That is, method number 1 has median value M1 and it is the lowest value, median value. So what we can see, we can say that method number 1 is least effective teaching method. And method number 4 is the best, is the most effective So you can see here, based on the score for different methods for teaching a subject, we can conclude that method 4 is most effective teaching method for this subject, and method 1 showed worst value. That is why it is least effective teaching method for this subject. Another important thing is method 3 and method 4 is showing average performance. These two methods, method 2 and method 3, showed average performance for subject, for teaching the subject, because here the median value is in the average, in between M1 and M4. So this is how you can analyze the box plot. You can use a box plot to analyze your data distribution. You can create box plot and you can get 5 values with the help of box plot, that is maximum, minimum, median value, Q3, Q1 and interquartile range. And then using the box plot you can derive the conclusion from the data. That's all in this slide. In the next slide I have presented the summary for this session. So in this session I have covered, we discussed the box plot, we visualized the data distribution with the help of box plot. In the next slide I have presented, that is in part 3C, we will discuss violin plot. That is the third plot to visualize data distribution. And then we will discuss programming example. In Python for these plots, for all 3 plots. So thank you very much. That's all from my side in this session.